Good afternoon. Hello, are you able to hear me? Okay, good. I'm so sorry, I was facing a lot of network issues. So, yes, good afternoon. Did you all just go through the properties of determinants and the determinants as a chapter? Good afternoon, all of you. And yes, you all practice. And we will be doing lot many sums on determinants. Only the thing is, people who have got exams from May 7th, just to take care of them, we are just doing it in a hurry. So even if you understand 70-80%, it's fine because we'll be solving the sums. Actually, you understand the best only when you solve the sums. We were doing properties last time, if you remember. So I will just show you one or two sums on properties, and then we will go. Okay. Yes, Tom, I will answer it. Huh? Now, so they can give you MCQs manner like this. Evaluate. X plus y, z 1, y plus z, x 1, z plus x, y and 1. So, or anybody who has a problem in this chapter, you can always WhatsApp me on the number, no issue. I will reply, I will clear all your doubts because you got Scottish test. No problem. Thank you so much. Okay, now they will ask you what is the value of this, and they may give you 4 options. See, which is the best way to do now? You change your first row to R1 plus R2. So when you are adding R2 to the corresponding element of R1 using the property, the value of the determinant remains unchanged. Do you remember? We did the properties. You can multiply to any row or any column and then add or subtract. Still, the value of the determinant remains unchanged. So I added Z to this, I added X to this, I added Y to this. And I came up to this determinant. So the value of this determinant is same as the value of the given determinant. Now, if I take X plus Y plus Z common from the first row, I will have 1, 1, 1, Z, X, Y, and 1, 1, 1. So when you have 2 rows identical, the value of the determinant will come 0. So it is going to be X plus Y plus Z into 0. So they will be giving you one of the options as 0. Perfect, Shreya. You understood? This kind of sum you can expect in determinants and minors, cofactors, find the value of K, if equations are consistent, area of triangle. These are typical sums. Oh, you don't have my number. Himmangi ma'am, please requesting you to send my number. Because if they have got exam and if they have any doubts, I can reply to them.
Yes, ma'am.
Thank you so much. Because, I'm doing these chapters in one lecture. So there is a chance that they may have doubts. Huh? Thank you very much. Chalo, then we are done with this sum. Everybody is clear about it? And we will be solving lot many sums on properties later. But now is the time to introduce matrices. Because your exam starts from May 7th, I guess. So we may not get one more lecture. Yes, Ashwar, thank you. So I will be introducing matrices. Now people from ICSE, properties were not remaining. Oh, its exam is postponed to May 17th. Okay, great. So let me introduce matrices today, and if we get 2 more lectures, it is good that we'll be solving only the sums based on both. That will be great. No, last one property was left, Shreya. Last one property was left. So that property actually I can cover up when I'm doing the problem. Sorry. Basic, all properties are done. Only one last one was left. I think, see, the last one, what we did was if each element of any row or column is multiplied by some constant and the products are added, just now what we used, correct? So you want me to give you that property, the last property? Because that actually I was thinking that while doing the sums, I will do. The last property I can give you just now if you want, so that basics of determinants will be over. Huh? The last property of the determinant is that if each element of a determinant above or below the main diagonal is 0, then ये MCQ के लिए अच्छा है property. Then the value of the determinant is equal to product of the diagonal elements. ये थी last property. See, like suppose if I have a determinant like this. So ये रहा मेरा main diagonal. अगर मेन डायगोनल के ऊपर में या नीचे में वन ऑफ देम इससे 0 0 0 यहाँ पे if all yes of course. So what you are asking now, if all elements in any row or column, obviously it is going to be 0, but यहाँ all नहीं है because ये नहीं है 0 ना. This is not 0, this is not 0, this is not 0. या तो above the diagonal या तो below the diagonal. ये हो गया मेरा above the diagonal और ये हो गया मेरा below the diagonal. One of them. If all are 0 0 0. Suppose यहाँ 0 0 0. Okay. समझा? Then the value of the determinant is product of the diagonals. Okay. When we solve the sums now, you will come to know. Excluding the main diagonal. Yeah. Perfect. Got it? Sure. Anyway, this property I will be explaining because there are 2-3 sums of MCQ now. We'll do, and that time again I'll come back with this. Now matrix is a singular, matrices is a plural. Again, it is arrangement of numbers. Yeah. Arrangement of numbers. Yes, Rutuja, you're right. In rows and columns. In rectangular or circular bracket. We to use up to 12th standard only rectangular bracket. And you know, determinant has a value. Matrix does not have a value. Understand that. Secondly, determinant number of rows are equal to number of columns. But in matrices, number of rows need not be equal to number of columns. So if any matrix, say A, has m rows and n columns, then its order of the matrix is m by n. It is written as m by n, and every determinant is a matrix nahi hai. Determinants are different, matrices are different. And I would really love to talk about determinants and matrices, where we use, how, who invented and how. But after this lecture, if we are getting extra lectures next week, I would definitely tell you, because everybody wants to know where are we going to use it. Correct? Yes. So that, let me complete this. Then, yeah, matrix does not have a value. Determinant has a value. Matrix में number of rows and number of columns need not be equal. Determinant में number of rows and number of columns are always equal. And यहाँ what I was telling, number of elements same यहाँ पे, वहाँ m square बोले हम लोग, m into n. Okay. Now in general, no, I write Aij. This is the way we represent a matrix, m by n. What does this mean? Name of the matrix is capital A. Its order is m by n, means it has m rows and n columns. And every element is represented by Aij, where it lies. Yes, position of the element in the grid. Superb. Ith row and jth column. This is the first thing that you should know. This is the way we denote any matrix. Then, if matrix A and matrix B are equal, then their corresponding elements are equal. And obviously goes without saying they are of same order. Replica, जुड़वा मैंने. I'll give you an example. If my matrix A is 1, 2, 3, and matrix B, if you are from ICSE, you have done, not all have done, is A, B, C. So iski order hai, there is 1 row and 3 columns. So iski order hai 1 by 3. Iski bhi order hai 1 by 3. So unke order same hai. And if A is equal to B, then corresponding elements will be equal. मतलब यहाँ बैठा हुआ is same as यहाँ बैठा हुआ. That is, A is 1, B is 2, and C is 3. That is called corresponding elements are equal. And vice versa. If matrices of the same order and corresponding elements are equal, then the two matrices are equal matrices, or they are same. Then comes types of matrices. This is my third point. Now the first type is a row matrix. Second is a column matrix. Third is a null matrix. Fourth is a rectangular matrix. Fifth is a square matrix. अभी जिन्होंने ICSE में थे उन लोगों को तो ये रिवीजन है बस. Row matrix has only one row. कितने भी columns हो, row will be only one. तो इसकी order रहेगी 1 by anything. Correct? column matrix में it will have only one column. कॉलम एक रहेगा, रोज कितने भी रह सकते हैं. ऑर्डर आई विल राइट, ये जो हमने लिखा था वो रो मैट्रिक्स है, ये है वो कॉलम मैट्रिक्स है. कॉलम इज वन, रोज कैन बी 1 2 3 4 5 6 and on. Correct? Are you clear about people who have not done earlier? Do they understand this? Is everyone from ICSE and all have done? No. Okay, then I have to go slowly. ठीक है, रो मैट्रिक्स हो गया, कॉलम मैट्रिक्स हो गया. Then we go to null or a zero matrix. It is represented by O. It can be of any order. Each element is zero. Each element is zero. Okay? First time. Rutuja, but if you have any problem, please feel free to tell me. Have you understood? Everybody has understood row, column, row matrix, column matrix, null matrix. Very good. Now, we go to rectangular matrix. See, अपना नाम थोड़ा logic use करो. Rectangle में क्या होता है? Adjacent dimensions are not equal. Means number of rows are not equal to number of columns. Means m is not equal to n if m by n is order. Right? Okay. So, see here, I explained you what is a matrix. Then the denotation, yes, no, that is later, beta, nakshatra. Then I explained you ith row jet column, then equality of matrices. Then we did types of matrices. Abhi I will be doing square matrix. Now square matrix, number of rows are equal to number of columns. मतलब इसकी ऑर्डर रहेगी m by m. All right? Yes. And number of elements रहेंगे m square और n square. Order रहेगी m by m. All right? Now only square matrix. This is the first thing that I want to tell you. Second thing, only square matrix has the corresponding determinant. Because determinant में चाहिए ही अपने को number of rows and number of columns are equal. Means if A is a square matrix of order m by m, implies then determinant A is possible. Okay? This will be determinant of the square matrix A. All right? Now if value of the determinant is 0, then it is called a singular matrix. And if the value of the determinant is not 0, then it is called non-singular matrix. And ये तुम लोग 12th में पढ़ोगे. Just I am giving you the information that इसका non-singular matrix का ही inverse रहता है. So you understood what is a singular matrix, what is a non-singular matrix. So singular matrix has to be necessarily a square matrix whose determinant is 0. Is that clear? Yeah, null matrix is a 0 matrix. Absolutely correct. But ये जो null matrix है ना, ये जरूरी नहीं है कि वही order का हो. You can have this way also. Singular and non-singular are included in square matrix, correct? Because singular है या non singular है, कौन decide करेगा? Determinant decide करेगा. Determinant के लिए क्या होना जरूरी है? Number of rows and number of columns equal. So matrix, null matrix will have value 0 only if it is a square matrix. A inverse है ना, वो मैं A inverse वो actually तुम लोगों को 12th में है. जैसे अपना algebra का, just because you asked, I'm telling you algebra में कैसे है? Algebra में A into 1 upon A is 1. वैसे मैट्रिक्स अलजेब्रा में है A any matrix into इनका inverse is unity. Unity हम लोग बोलते हैं I is a unit matrix, but that you will be learning in the 12th standard. But just I am telling you, क्योंकि 12th में जाते जाते भूल जाते हैं लोग non singular matrix. That's why I am telling you non singular matrix only will have A inverse because उसके determinant के value is not 0. These terms singular non aren't for other types of matrices. No, हो ही नहीं सकता ना, determinant होगा ही कैसे? Number of rows and number of columns are unequal. Correct? Understood, Rutuja? Yes. So that's why I am taking a long arrow and writing all about square matrices. Number of rows and columns are equal. Then if determinant is 0, singular, determinant is not 0, non-singular. Abhi third what I want to tell you is diagonal element. जो डायगोनल में नहीं है वो नॉन डायगोनल एलिमेंट्स. अभी I will give you an example, you can understand better. Suppose if I write a determinant or sorry matrix of order 2 by 2. अभी तुम्हें तो पता है सबको, this lies in first row and first column, first row and second column, second row and first column, second row and second column. यहाँ भी है A11, A12, A13, A21, A22, A23, A31, A32, A33. करेक्ट? हाँ, ये दोनों स्क्वायर मैट्रिसेस है. अभी आप लोग मुझे बोलोगे जो स्क्वायर रहता है उसको ज्योमेट्री में दो डायगोनल्स रहते हैं, फिर डायगोनल एलिमेंट्स यही क्यों एंड ये क्यों नहीं? Because see here, if I mark these or if I mark these, यही diagonal elements है क्योंकि ये elements है Aij where I is equal to j, है कि नहीं? देखो A11, A22, A33, A44. So Aij where I is equal to j, they are called non-diagonal elements. They are called diagonal elements. And if in a square matrix Aij where I is not equal to j are non-diagonal elements. रेक्टेंगुलर मैट्रिक्स में, रो मैट्रिक्स में, कॉलम मैट्रिक्स में, जहां रेक्टेंगुलर मैट्रिक्स है, नंबर ऑफ रोज एंड नंबर ऑफ कॉलम्स आर नॉट इक्वल, वहां डायगोनल नॉन डायगोनल एलिमेंट्स होंगे ही नहीं. फ्रॉम लेफ्ट टू राइट और फ्रॉम बोथ साइड्स टू हीन. Can I take this? Tell me. I will write. Tell me. Yeah. I will write B11, B12, B21, sorry, B21, B22. Your question is, can I take these? Is 1 equal to 2? I equal to j. So here you got it. Aij 1, 1, 2, 2, 3, 3, 4, 4, 5, 5. They are diagonal elements. Understood? Very good. So ये नहीं रहेंगे diagonal elements. You are welcome to him. ये diagonal elements नहीं रहेंगे All of you are clear? So पहले याद रखो स्क्वायर मैट्रिक्स में सिंगुलर नॉन सिंगुलर रहते हैं, स्क्वायर मैट्रिक्स में डायगोनल एलिमेंट नॉन डायगोनल एलिमेंट्स रहते हैं. आप अगर मुझे पूछोगे कि मेरा ये मैट्रिक्स है A11 A12 A13 A21 A22 A23, so you may ask me, is this the diagonal because I is equal to J? No, because ये incomplete है. You understand? ये rectangular matrix है. Diagonal elements, non-diagonal elements will be there only in a square matrix. Is that clear? ये रेक्टेंगुलर मैट्रिक्स है, तो 1 1 2 2 होके भी दे विल नॉट बी कॉल्ड डायगोनल एलिमेंट्स. ऑलराइट, yes, yes, absolutely correct. I'm so happy somebody asked me this. If I have a matrix of order 1 by 1, ये रो मैट्रिक्स भी है, ये कॉलम मैट्रिक्स भी है, ये स्क्वायर मैट्रिक्स भी है, तो एंड इसका पोजीशन है A11, तो ये डायगोनल एलिमेंट भी है. ओके, गॉट इट? यू आर वेलकम. So everybody understood about the square matrices right from the beginning? Diagonal, non-diagonal? Because you have to take it as a flow. मैं यहाँ तक आ गई हूँ डायगोनल एलिमेंट्स, तो अभी मैं जा रही हूँ डायगोनल मैट्रिक्स. Diagonal matrix. Ashwath, thank you so much. Understood everything. अभी डायगोनल मैट्रिक्स, डायगोनल नाम है तो स्क्वायर तो हो गया ही पक्का. करेक्ट. डायगोनल मैट्रिक्स को भाव है सिर्फ डायगोनल को, तो सारे नॉन डायगोनल एलिमेंट्स जब भी जीरो रहते हैं या कुछ तो आएगा 1 2 3 और एनीथिंग, all non-diagonal elements are zero. यहाँ 1 2 3 के बजाय जीरो चलेगा, लेकिन नॉन डायगोनल पक्के जीरो रहेंगे. Diagonal matrix. Understood? So non-diagonal matrix is necessarily a square matrix, because diagonals होते ही है square matrix में. In which non-diagonal elements are zero. Okay? Got it? अभी है अपर ट्राइंगुलर. Very good. Yes, Rutuja. Value of the determinant will be 6 here. Yes. Upper triangular and lower triangular. Matrix. थोड़ा है ना, तुम लोग ध्यान दो नाम पे. अपर ट्राइंगुलर, अपर मतलब सारा वेट ऊपर. तो अगर मेरा ये डायगोनल है, अपर ट्राइंगुलर में डायगोनल का सारा वेट ऊपर मतलब नीचे नीचे जीरो. यस, यू वांट मी टू स्क्रॉल अप? यस श्रेया. और चाहिए? डू यू वांट मोर? ओके, कहाँ तक बोलो? दिस इज ओके. अब डायगोनल चाहिए इनको। Done. Very good. Now can I go further? Yeah. अपर ट्रायंगुलर समझा, सारा वेट ऊपर, नीचे कुछ भी नीचे जीरो ही चाहिए. You want me to write elements below the diagonal? All elements below the diagonal are zero. You can judge now what will be lower triangular. सारा वेट नीचे, मतलब ये डायगोनल है. Yes, yes. No, Shriya, all elements. अच्छा, अपर ट्रायंगुलर में पूछ रही हो? हाँ चलेगा चलेगा, अपर ट्रायंगुलर में चलेगा. मैंने क्या बोला? माय कंडीशन इज ऑल एलिमेंट्स बिलो द डायगोनल आर जीरो. ऊपर हो भी सकते हैं, नहीं भी हो सकते. ऐसा नहीं बोला कि होना ही नहीं चाहिए. गॉट इट? जैसे ऑल एलिमेंट्स above super, all the elements above the diagonal are zero. इसको बोलते हैं लोअर. तो देखो ना, लोअर एंड अपर को कंबाइन करके एक्चुअली मेरा डायगोनल मैट्रिक्स हो गया, ऊपर भी एंड नीचे भी, राइट? So it came as a flow, square matrix. Then diagonal elements, non-diagonal elements, then all non-diagonal elements, zero is diagonal. Above the diagonal are zero, lower triangular. Below the diagonal are zero, upper triangular. Abhi I will go to the next, that is a scalar matrix. But these may be rare cases of matrices. Yeah. Anything they ask from any corner. See, this determinant matrices, if you're perfect with your theory partner, you can answer 95% of the even JEE level questions just by judgment, without solving also. Okay. Yes. Now scalar matrix. Scalar बोला तो आंखों के सामने क्या क्या आना चाहिए? It is a square matrix. It is a diagonal matrix. Plus all diagonal elements are equal. ये देखो, ये अपना डायगोनल एलिमेंट, ये था अपना कहाँ गया? यहाँ अलग अलग थे 1 2 3. ये स्क्वायर मैट्रिक्स था. ऑल नॉन डायगोनल एलिमेंट्स वेर जीरो, बट डायगोनल एलिमेंट्स कुछ भी थे. अभी अगर यही डायगोनल एलिमेंट सेम रहेंगे, 2 0 0 0 2 0 0 0 2, तो ये हो गया मेरा स्केलर मैट्रिक्स. Got it? This is called a scalar matrix. You know, every time I am not wasting time, I am making it very clear to you कि ये MCQ में पूछ सकते हैं, true false में. It's a scalar matrix है तो आंखों के सामने आना चाहिए. Square matrix भी है, diagonal भी है, plus diagonal elements are equal, right? Okay. Yes, yes. right? Yes, Tuhin. You can have upper portion में 0, but lower portion पक्का 0, 0, 0. 3 by 3 में. Understood? मतलब अपर ट्राइंगुलर मुझे एकदम मैथमेटिकल लैंग्वेज में लिखना है ना, अपर ट्राइंगल में इज अ स्क्वायर मैट्रिक्स Aij is 0 when I is greater than j. बाद में सोचो मैंने क्या लिखा. अंडरस्टूड ना? ऑल जीरोस आ गए तो वो हो गया डायगोनल मैट्रिक्स. इट हैज अ सेपरेट नेम बेटा. करेक्ट. नीचे तो ऑलरेडी 0 है. आप अगर ऊपर भी सारे 0 लिखोगे, diagonal matrix is always a square matrix. Yes, yes. And lower में क्या लिखोगे? All Aij are 0 if I is less than j. Correct? And diagonal में क्या लिखोगे? All Aij are 0 when I is not equal to j. Yes, ये मैंने लिखा ना, ये देखो. अपर ट्राइंगुलर के लिए I greater than j, लोअर ट्राइंगुलर के लिए I less than j, and diagonal matrix के लिए I is not equal to j. Because in MCQs you may need this mathematical language, so giving you, right? So here we write Aij, all are 0 when I is not equal to j, and if I is equal to j, all elements are equal. Correct? I have लिखा है मैंने already. I don't have to write again. Now the next part is unit matrix or identity matrix. It is denoted by I. जो algebra में 1 काम करता है वो यहाँ unit matrix करता है. अभी यहाँ I of order 1 by 1 कैसे लिखना है? ऐसे. Unit matrix of order 2 by 2 कैसे लिखना है? 1 0 0 1. I of order 3 by 3 कैसे लिखना है? 1 0 0 0 1 0 0 0 1. Well, how will you compare scalar matrix with unit matrix? How will you compare? It's a square matrix. It's a diagonal matrix. It's a scalar matrix in which each diagonal element is unity. That is 1. Yes, unit matrix is also a scalar matrix. I wrote here. See. You can go up to any order, 1 by 1, 2 by 2, 3 by 3, but for you in the syllabus, you have only up to order 3 by 3. Okay? Got it? If all elements have to be 1, the determinant, yeah, correct, excellent, yes. इसके प्रॉपर्टीज भी है जो एमसीक्यू में हम लोग यूज करते हैं, which also I will be taking. Means, you know, any matrix into unit matrix is same as I into A, and it is A. It is like algebra. And other thing is any matrix into null matrix or null matrix into any matrix, the answer will be a null matrix. तुम लोगों को एक अजीब चीज बोलूं, unlike algebra na, sometimes you know what happens, matrix A is not null, B is not null, but product of the two is null matrix. ऐसे भी होता है, unlike algebra. Then these are called divisors of zero. Divisors of null matrix. ऐसा होता है, we'll do one sum on that. Both are not zero, but उनका product zero रहता है. And that is null matrix रहता है. Algebra में तो ऐसे नहीं होता है. When we say product of the two is zero, either of the two is zero or both are zero. I think probably you will have it in the 12. Property देने में क्या है अभी? I'm just giving you. Rutuja, I didn't get your question. One can be up. हाँ वैसे. हाँ. Without that also. ये नहीं समझा तो भी चलेगा, Shriya. I said unlike algebra, even if individually the matrices are not null matrices, sometimes their product can come zero. You will be doing it next year. Just for information, ऐसे आया इसलिए बोल दिया. हाँ? Yeah. This you need not use it for this year. You don't need. Now I go to the next part. If you want, I can cancel this number so that for exam, yeah, their examples will be interesting. Yes, Rituja, and I will take one of them, definitely. अभी तो exam का वो pressure है ना, तो thank you so much for understanding. Then you have transpose of a matrix. It is written as A dash or A raised to T. Now, देखो, if I have a matrix A, 1, 2, 3, 4, 5, 6, transpose of this matrix, you write first row as first column, second row as second column. All right. So if A has order m by n, इसका order रहेगा TRANSPOSE, transpose. You want me to write again? Okay. इसका order रहेगा n by m. Rows are written as columns, columns is written as rows. Now, just for your test, remember a few things. Determinant of A is same as determinant of A transpose. Must remember this. A transpose का transpose A नहीं होगा क्या बोलो? ये है A, इसका transpose ये निकाला. अगर इसका फिर से transpose निकालना है तो first column will become first row, second column will become second row. Correct? No, they need not be. No. इस स्क्वायर मैट्रिक्स का यहाँ खत्म होता है. No, here only if A is square ना, determinant होगा ही अगर square है तो वो मुझे बोलना ही नहीं है. नहीं तो determinant आएगा ही नहीं. याद ही रखना है. Okay. स्टार वाला एमसीक्यू के लिए याद रखो, हाँ. Rows and columns are interchanging. Yes. 4, 5, 6 first column. नहीं 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 रुतुजा. First row becomes first column. Second row becomes second column. You cannot write first row as second column. Got it? नहीं तो ना आप सोचो ना, अगर वैसा होगा तो डिटर्मिनेंट का वैल्यू विल चेंज इन द साइन using the property what I taught you last time. If rows are interchanged or columns are interchanged, then the value of the determinant changes in the sign, right? Okay. So remember this, ये MCQ के लिए काम आएगा. और एक symmetric matrix, too much of theory, na? If any matrix is equal to इसका ट्रांसपोज, तो नेचुरली अभी क्या होगा, ए स्क्वायर मैट्रिक्स ही होगा, नहीं तो दोनों के ऑर्डर कैसे सेम रहेंगे. तो सिमेट्रिक मैट्रिक्स होता है जब भी ए एंड ए ट्रांसपोज आर इक्वल. I'll give you an example. ये मेरा ए है, अभी ए ट्रांसपोज लिखो. ये फर्स्ट रो उठा के फर्स्ट कॉलम में डालो 2 5, सेकेंड रो उठा के सेकेंड कॉलम में डालो 5 -3, है दोनों सेम, implies that A is symmetric. Correct? Getting? Symmetric के बाद है skew symmetric, where A is minus of A transpose. Again, A will be a square matrix. I'll give you an example. Skew symmetric, where the matrix A is minus of its transpose. चलो पहले transpose लिख लेना. First row will become first column 0 and -7. Second row will become second column 7 and 0. Therefore, minus of A transpose. डिटर्मिनेंट में हम लोग क्या करते हैं, डिटर्मिनेंट में हमें जब भी मल्टीप्लाई करना है तभी एक रो या एक कॉलम को करते हैं. Whereas no, need not be. I'll give you another examples also. जरूरी नहीं, स्क्वायर तो होगा ही, स्क्वायर मैट्रिक्स तो होगा ही सोहम, बट नीड नॉट बी नल मैट्रिक्स. नल स्क्वायर नहीं होगा एवरी टाइम. See, in determinants, if my D एक छोटा लेती हूँ तो तुम लोगों को समझेगा, ये डिटर्मिनेंट, then K times D will be KA, KB, C and D. मतलब we can multiply only one row or one column. Correct? But if I write D as matrix A, B, C, D, then if I want to multiply this matrix by K, it will be KA, KB, KC, KD. Understand the difference? Scalar multiplication. It is called a scalar multiplication. You will be multiplying each term by the same number, not any one row or one column like determinant. Getting it? तो अगर मेरा ये A ट्रांसपोज है तो मुझे माइनस A ट्रांसपोज चाहिए, मतलब आई हैव टू मल्टीप्लाई ईच टर्म बाय -1. सो ये दोनों तो जीरो ही रहेंगे, ये रहेगा 7, ये रहेगा -7. सो इज इट नॉट योर A? So in this case, A is equal to minus of A transpose. If A is equal to A transpose, symmetric. And if A is equal to minus of A transpose, skew symmetric. और दोनों भी नहीं, ऐसा भी होता है, दोनों भी नहीं, तो it is neither symmetric nor skew symmetric. You understood the difference? Multiplication, scalar multiplication in a determinant and in a matrix. Symmetric, skew symmetric. For MCQs, I can give you. The exam nahi hota, so I would not have given so early. The diagonal element remember this. Okay? Now, one more thing actually I want to tell you. They tell you to write any matrix as symmetric and partly symmetric and partly skew symmetric. वो कैसे करना है? Express. Wait, let me take photos of these notes. Himangi ma'am. Hello. Is it possible for you to send photos of this? She's not there on the line, can I can. I will write to madam. Okay. I will make sure that you get it because there are too many to write. You can see the recording. Okay. Okay. I wanted to take one or two sums for you to understand. Matrices of the same order can be added or subtracted. Are you aware of this? But I can do A plus B only if A and B are of the same order. Sushant, that is okay. But how do I send? There is no way I can send it. I don't have anybody's numbers, no? We can tell, okay, but I remain the host only for the lecture, na? I will request Himangi ma'am, file save karon theva. I will have to talk to her if it is okay, na? I don't mind doing, but I have to ask her. Which point? Saksham, ये point नहीं समझा. Matrices of the same order can be added. ये नहीं समझा. अच्छा. See, I'll give you an example. अगर मेरा A है 1 2 3 4 0 minus 1 and B है 1 4 5 6, अगर मुझे ऐड करना है A plus B, तो we add corresponding elements. हाँ, तो 1 का करस्पॉन्डिंग ये है A1 1 B1 1, इसका करस्पॉन्डिंग ये है, फिर इसका करस्पॉन्डिंग ये है, और 2 का करस्पॉन्डिंग ये है, फिर ये दोनों को है कौन करस्पॉन्डिंग में, करेक्ट. So you have to have the same order, but if your A is 1 2 3 4 0 minus 1 and B है 0 2 minus 1 3 1 2, इसका ऑर्डर है 2 rows and 3 columns, इसका ऑर्डर है 2 rows and 3 columns, then their orders are same, so A and B can be added. मतलब you will be adding A11 with ये B11, that is this will be 1 plus 0, 2 plus 2, 3 plus minus 1, then you will have 4 plus 3, 0 plus 1 and minus 1 plus 2. So this is going to be 1 7 4 1 2 and 1. ये आंसर आएगा A plus B. Saksham, are you clear about point number 2? Matrices of the same order can be added or subtracted. Understood or no? ये सब algebra of matrices है. Okay? Addition समझा सबको? Yes, ma'am. It's my brother's name. Actually, he changed. Oh, I didn't get it. Okay. What I wrote, A plus B is equal to B plus A. ये property को आप क्या बोलोगे? क्या बोलोगे आप? Matrix addition is array superb commutative. अगर 3 matrices ऐड करने हैं A, B, C, so you can add these two पहले and then add it to A. You can add A and B then C. So what we say, matrix addition is associative. Then I have already given you this A plus null matrix. Correct? All of you got it? Then मैंने already scalar multiplication समझा दिया है. How to multiply. Okay? Now we'll do one sum. थोड़ा एप्लीकेशन बेस करते हैं व्हाट यू लर्न टुडे. हाँ, चलो प्रोडक्ट करना था मुझे, बट अभी नहीं होगा ये लेक्चर में. This product is quite not that easy to end the lecture with. Example 1, yes. Find K if matrix A is singular. अभी ये स्क्वायर मैट्रिक्स है. सिंगुलर मैट्रिक्स के लिए यू हैव टू फाइंड द डिटर्मिनेंट. So it is this into this minus this into this. Now, because A is singular matrix, determinant A is 0. So जो अपना value आया, got it? Super. Chalo, I'll give you the next one. If 2A plus B, 3A minus B, C plus 2D, 2, 3, 4 minus 1. So you have to find A, B, C, D. Now by equality of matrices, अब इस subject का जमाना ही नहीं है, so why I am writing is to make you understand कि equality of matrices may be equate the corresponding elements. ये और ये equate करो, you will have 2A plus B is 2 and 3A minus B is 3. Then you will have C plus 2D is 4 and 2C minus D is minus 1. अभी solve करो, यहाँ तो add ही करना है. 5A is 5, implies A is 1. A1 and B0 आया, super. अभी ये solve करो. C plus 2D is 4. यहाँ multiply करो 2 से. 4C minus 2D is minus 2. 5C is 2. C is 2 by 5. Got it? अभी D निकाल. Twice C. ये -1 में ये बाजू ले रही हूँ. +1 is equal to D. So 4 plus 5. So I get D as 9 by 5. ये एक टाइप का सम है. Construct the matrix A of order 3 by 2. So अपने को अभी 3 rows and 2 columns चाहिए. So कैसे लिखोगे 3 rows? 2 ही columns चाहिए. A11, A12, second row, second column, third row. See, there are 3 rows and 2 columns. Correct? All of you understood how to write? So अपने पास है Aij is I minus 3j. ये फॉर्मूला दिया हुआ है. So अभी अपने को निकालना है A11, A12, A21, A22, A31 and A32. ये सारा निकालना है. अभी Aij है I minus 3j, ये दिया हुआ है. अभी यहाँ 1 में I is 1 ना j is 1. So 1 minus 3 into 1. This is -2. I के जगह 1, 3 के जगह, j के जगह 2, -5. फिर ये आ गया I के जगह 2, j के जगह 1. Getting it? यहाँ 3 आएगा. आया. So we have to design matrix A. First row है -5, -1. Second row क्या है अपना -1, -4. Third row आया 0 and -3. All of you understood how to design construction of matrix when they give you the general order. Yeah, -2, -5 in the first row. Hey, मैंने क्या लिखा? Yeah, I think वो scrolling में गया मेरा number. -2, -5, -1, -4, 0 and -. ये आंसर है. Check. आ गया? Construction of matrix समझा? Okay. Understood, na? Yes, thank you, Turin. Now, I think you have a lecture, no? Yes, clear with it, na? Thank you so much. Very good. So, you have a lecture at 6 p.m. Okay, chalo, bye-bye. Have a nice day. Thank you very much. Stay blessed. We'll do more sums next time. All right? Should I give you notes? Himangi ma'am, are you there? Bye-bye. Thank you. I will have a word with her and I will make sure that you get the notes. In case if you don't get, you let me know. Thank you so much. Bye.